Okay, this will be our Unit 5 test review. These are the pretest questions. Number 1 we did earlier, but I'll redo it now. We want to find the inverse of a function. Step 1, we exchange x and y. So first, exchanging the x and y, I will write x is equal to y squared plus 9. Then we will solve for y, subtracting 9 on both sides. We have y squared is equal to x minus 9. I've just exchanged the side of the equal sign. Now taking the square root, I have y is equal to the square root of x minus 9. That's the inverse. Here you can see we're squaring and adding. Here you can see we're taking the square root and subtracting. It's the undoing. Number 2. Question sentence. Which are true about the domain and the range of the inverse function? It says we have these two functions. Let's take a look at Desmos to shed some light on this. You can see I've graphed f of x is x squared minus 7. Here we have a parabola shifted down 7 units. The vertex is down here at 0, negative 7. That's because of that minus 7. And now we're going to enter in the square root. We're going to enter in the second function, g of x equals, they use f inverse, I'm just using g of x here. I want the square root. One way I can enter it is I can enter it in a parentheses and put it to the 1/2 power. The 1/2 power is the same as the square root. And I'm going to demonstrate that by making another function, h of x, and in this case I will use the square root symbol. In Desmos you can hit the little keyboard and then there's the square root symbol. If you need stuff that's not here, go to functions and then you can pick miscellaneous as some useful stuff. There's the nth root, but we have the square root right here. I can do x plus 7 and you're going to see it's going to correspond with the green. You can see the green one and the purple one coincide. Purple, green, purple, green. The 1/2 power is the same as the square root. All right, so we want to restrict the domain of our original function. We don't want it to be 1-to-1. We want it to be 1-to-1. So you can see this function is not 1-to-1. Essentially, we're going to go to our vertex and we're going to only graph domain elements to the right of that. So the vertex of our domain is 0, negative 7. I only want to graph x values greater than 0. So come onto this line where our original function was. Do open bracket. That's the standard symbol for a set. We want x, then greater than or equal to is down here on the keyboard, 0. Now you see we have only half of our parabola. Now it's 1-to-1. What you can see now is the graphical ideal of an inverse. These two functions are reflected about the line y equals x. Separately, I'm going to graph that y equals x. And all these that I used function notation, I could have used simply y. Here you can see. So here you can see the purple function and the red function are mirror images across this line y equals x. That makes sense because if they're inverses, it's the exchanging of the x and the y. It makes sense that they would be flipped about that line. This particular question though says which are true of the domain and range of the inverse function. Well, let's look back at the graph one more time. The domain, the purple function is the inverse. The domain will be, starting right here, it will be values negative 7 and greater. The range will be strictly greater than 0. You can see the graph is entirely above the x-axis. Why will it be greater than negative 7? Because if you put a number less than negative 7 in this function, you would have negative plus a positive to get a negative number. And the square root of a negative is not a real value. It would be our I value, and that's what we mean here. It's not defined over the real numbers. So our domain is going to be greater than -7, our range will be greater than 0. Essentially, you might consider this the starting value of the function. All of our other y values are higher than this, or equal to. All of our other x values are to the right of it. So the domain is x greater than equal to -7. Yes, that's true. The range, no, it's not greater than equal to 7. Domain greater than 7, no. Range, y greater than 0, yes, that's true. So we got a yes, no, no, yes. Number 3, the function f inverse is the cube root of x plus 16 is the inverse of which function? Well, we just need to find the inverse. So exchanging the input and output symbols, where it says f inverse, I'm going to write x. Where it says x, I'll write y. Now I'll undo the function by cubing both sides, cubing the left and cubing the right. I am cubing both sides because the function is the cube root. It is the undoing. Cube both sides. On the right hand side, the cube cancels with the cube root to leave just the inside expression y plus 16. Here I have x cubed. Solving for y, I'll subtract 16 on both sides. So I have y equals x cubed minus 16. And that is C. And you can see that the relationship, that they are inverses. This is cubing and subtracting. This is adding and taking the cube root. Here we have added 16, here we have subtracted 16. Here we are taking the cube root, here we are cubing. They are very clearly the undoing of each other. Number 4, which feature of a square root function is not changed by horizontal translation? Well, the square root function, if you graph f of x is equal to the square root of x, looks like this. If you make a horizontal translation, that is if you move this thing right or left, which is not changed. The initial point location, that point is certainly going to be changed if we shift it right or left. If we shift that right or left, we're going to change that point. The domain, if we shift this right or left, we're going to change the domain because a horizontal translation, it is an x change, and domain is x. Both of these will be changed. The end behavior, as x tends to plus infinity, y is going to tend to plus infinity. That is not going to change. No matter where I shift this function left or right, that's going to remain the same. But the end behavior moving this way would change because that point's going to change. Here, as x tends to negative infinity, y is 0, doesn't approach 0, y is equal to 0. So we don't typically talk about the end behavior in this context, but it would change if we move this, then that endpoint's going to be slightly different. If you selected C, I'm okay with it, but it's what it's certainly going to be. So we're saying the end behavior is going to change. That is, this second one will change to wherever our starting point. It will be related to our starting point. Our range, moving it left or right is not going to affect the range. The range is the y. A horizontal translation is going to affect the domain but not the range. D is correct. That's which one will not be changed.